Grinder and paint makes me the welder I ain't. I think I should give you fair warning that this is not going to be an overfed salesman bobblehead review where I plug it in and I grind some stuff and I tell you how great the thing is. I'm actually going to take it apart, see if the thing's any fucking good at all. Welcome back to the shop, gentlemen. Today we add a new toy to the stable, the DeWalt. This is the Makita killer, or so my colleagues on the dumb end of the tape tell me. As you can see, the stalls are already pretty filled up. I got lots of Makitas there. And when it comes to grinders, I prefer Percherons to Arabians, so we're going to see which one this is. You're probably thinking to yourself, why the hell does he need so many grinders? Well, my friends, this is a high production hobby shop. And the first are La Première Étoile. We have zip cut, flap wheel, cup, wire wheel, regular grinder, diamond, and another zip cut that just happens to have a broken disc. When you don't get a friggin' fart changing the wheels mid-project, it gives you an enormous sense of well-being. And the whole thing is with grinders is they're friggin' awesome. You can cut anything with them. So this DeWalt is more or less the challenger to the world champion 5-inch grinder, the Makita. I mean, for the past 30 years probably, this has been the grinder. Alright, pay attention because we're going to check out the marketing bullshit, see if it stacks up. 120 volts, 12 amps, 10,000 RPMs, 1837 watts in your hand. That's 2.5 horsepower they're saying here. Okay, so VAP equals IV. We go 120 volts times 12 amps, that's 144 plus 0, 1440. So where the hell are they getting 1837? I'll tell you where they're getting it, out of thin air. It's bullshit. Well, we got the box open. Yeah, it's yellow. Yeah, it's got the ugly DeWalt plug too. Nice skookum cord seems like though. Oh, we got some extras. Handle and a grinding wheel as well. The ones that come with the grinder are obviously shit consistently. And one of these things, face spanner. You might as well just throw this out right away because you're going to lose it anyway. Well, it feels real beefy. It's heavy. About 3.1 kgs, which if I'm not mistaken is about 200 pounds. And the Makita, the latest version of the Makita is 2.6 kgs. So about 10 pounds. So hopefully the extra weight is actually copper windings and not lead weights. But it's probably too much to ask for. Okay, one thing before we get too hung up on specs. The most important thing about any grinder is how it feels to you. Everybody's got a different shape of hand, everybody's got a different size of hand. So you got to make sure that it's comfortable for you. You know, you're holding a horsepower and a half in your hand for hours at a time. It's got to allow you to have the correct body positioning so that you're not fighting the tool all the time, you're working with the tool. I know I like the Makita. I don't know if I like the DeWalt yet. It feels okay. I know I hate the paddle style. It's horrific. Horrific. Some guys love it. I hate it. So that's all we're going to say about the Makita for this vid. Back to the stable she goes. Right off the bat, this is interesting. Quite a bit different than the Makita. If it weren't so much like cheating, I'd go and look at the parts stack up to make sure that the spring of things and clockworks don't fly out at me. But yeah, fag it. We got the top words of the business end prized off, and we got some interesting stuff going on here. This shaft here is 3/4, so you'd think that's nice and beefy, but they actually got to step that down because in behind here is a Lux, L-U-X. I couldn't even find the manufacturer, so hung low Charlie brand. 6001 bearing, which we all know the center of is only a 12mm ID. So that means what you see is not what you get. This actually has to get stepped down. And this is a real interesting gear. Doesn't look or feel like there's any grease on it at all. We'll get back to that in a second. So here's the housing. We see the pinion. It looks exactly the same, like there's no grease on it. Now this looks for all the world to me like molybdenum disulfide paste, which is a super duper expensive lubricant for high pressure gear sets and disc springs and real industrial stuff. And it's surprising to me that they would use this molybdenum disulfide because it's really expensive. The last time I sourced it, it was $1,000 for 20 liters of this stuff. But then I get thinking about it, and I can see that both the gears they look like they got no lube on them at all. And of course, open gear grease or molybdenum disulfide sticks to everything. It's particularly attracted to white couches, and that's why I'm not allowed to have it in the house. But on closer inspection, this is not that. This is just a gray, pasty kind of grease. It might have some moly in there, but you can see if you smear it, it's really thin, and it doesn't have much sticktivity to it. And if you smear it on your finger, it's almost like you can see little particles of that Moly Di-Sulfide in the grease. I could be wrong though, so let's have a look in the microscope. Just gonna take a little smear of this and put it on a piece of papier. We'll have a look under the microscope and see what we can see. Okay, so here's a little smear, and super interesting. You can see that there's actually, it's not homogeneous, it's heterogeneous, and there are particles of that gray material suspended in the grease. And we can see here at the very edge of the smear, yeah, there's some tiny little particles of molybdenum disulfide. But it's a real odd composition. I've never seen anything like that before. I think we can safely assume that it's been well engineered by DeWalt and they know exactly what they're doing. It's just nothing I've seen before. Kind of interesting. Now, having said that, of course, why is it that there is no grease on the gears? What's happening? So here's the pinion here, and consequently this is a spiral bevel gear set. I'll show you that in a second. But you can see there is no appreciable grease on the pinion itself, and you can even see at the interface here where the mound of grease is sitting and the gear is going through the grease, but it's not really sticking. So I guess they're relying on the molybdenum disulfide particles to get crushed into the gear face itself. Now this is a very well made gear. I would say it might even be a little bit better than the Makita. I remember the Makita, the hypoid saw anyway, had some chowdery marks at the very edge, but it could just be that this gear hasn't been used at all. Now let's have a look at the crown. Here's the top of the tooth on the crown, and you can see there's no machining marks. And it's rounded over nicely. That's totally different than the Makita, which had very prevalent machining marks. And then if we can see the root, down into the root here, if I can focus. There we go. That is a nice looking gear. And you can see what looks to be those molybdenum disulfide particles. Now, this gear face actually is pretty rough looking at it, almost like it's been sandblasted. So maybe, yeah, look at that. So maybe that's why we don't see the machining marks on the top of the tooth, because they've sandblasted them away. Okay, so, and there's the wear pattern there, the initial wear-in pattern of the crown against the pinion. Actually, looking at it now, this is a really rough gear surface. I'm assuming that they're using the molybdenum disulfide to fill in all those voids, and then it should polish up over time. But it's actually not as nice of a finish as the Makita hypoid saw. Apples meet oranges. If I had to guess at this, I would say this has been finished in a vibratory deburring media of some sort. So at first glance, it's good from far, but far from good when you get up close. It's all pitted. I imagine that's no big deal. It'll wear in nicely, I'm sure. And it helps if you file with the right end of the file instead of the handle. And that is that's hardened. And it's very hard. It's a lot harder than the Makita gear, actually. A lot harder. The file, basically the file doesn't even touch it. That's pretty close to file hard there. Right, so you can tell that this is a spiral bevel and not a hypoid because the pinion goes through the center line of the crown shaft. So we have the 3/4 shaft, which gets shouldered down to 12 millimeters, holding on this crown gear, and then it goes down to 1/4 inch, which is 6 millimeters. So really, you got this tiny little shaft. This is 2.5 horsepower. Remember that, according to the manufacturer. And you got a 6 millimeter stub shaft here and a tiny little bearing. Now they need to do that in order to clear this pinion. They could redesign that so it's a little bigger, but just at first glance it seems pretty anemic to me for something you're holding in your hand that's rated for 2.5 horsepower. That's their rating, mind you, not mine. I got the R2-D2 helmet off, and I'm just going to take a second to inure myself against sticklers. The difference between a grease containing molybdenum disulfide and molybdenum disulfide paste is a matter of semantics. But at least in my experience, paste has a much higher Moly Di-Sulfide content, like right around 80+%, whereas I think the grease has quite a bit less, as you saw with the microscopic view there, just tiny little particles suspended in a really strange grease. Like, it doesn't stick to anything. Look at this pinion, there's no grease on it. It's very odd. Okay, so here's the pinion. It's a big pinion. Awesome. And I also like, look at this, it's got a proper O-ring and then a dust seal there, a wiper to keep the grinding crap out. That's awesome. And then if we look at this bearing behind there, it's a shielded bearing, so we got double protection. Awesome. We got the motor rotor out, and here's the fan. Super cool. It's metal, incredible, but then you look at it, well, that's not really going to move even a tenth of the air as a squirrel cage would. But look at that. Hey, plastic underneath. Very, very nice. I'm impressed. Now this rotor, they did a lot of work to this. Obviously a quality rotor. Check this out. They potted down here by the commutator, and they balanced the living shit out of this thing. Look at it. Look at this, this is cute. It's still got the Chinese guy witness mark on here. You can tell the Chinese handwriting. I wasn't going to take the pinion off, but I'm glad I did. So we look at this here, and there's a 6200 bearing, so that's makes this an 8mm shaft and 30mm OD. But there's the pinion, and there's no key. So this is bizarre. They're relying on the friction between the clamping of this little nut to clamp it hard enough so that it doesn't spin free on this shaft. Basically the torque is going through the inner race and butted up against this. Now this is interesting too. It's got a labyrinth seal on there. Not only does it has a single lip seal, it also has a labyrinth seal going on. Keep the grease out of the motor and the dust out. Interesting. So yeah, let me know what you think of that. No keyway. That's wow. Yeah, blows my mind that it even works. That there's no keyway here. It boggles my mind. It really does. So I got to take a second and do something that they don't teach you in school unless you're a pilot or a sailor. We're going to do some dead reckoning on this. So this is an 8mm shaft. That means that's right around 4,000 pounds that it's clamping when it's properly torqued. Now this is cheese grade, so we'll derate that. We'll say it's 3,000 pounds. And so remember that number, 3,000 pounds. And the static coefficient of friction of steel on steel is 3/4, but we'll derate that, so we'll go half. Remember that number, half. Then, because we're talking about torque, we have to take the centroid. Anyway, so this shaft is 8 millimeters. That ID is 8 millimeters. That boss is going to be 10 millimeters. Half of that is going to be 5 millimeters, which is the radius. 25 millimeters to the inch, so that's 5 divided by 25 is 0.2. Remember that number, 0.2. So now we're going to go 0.2 times 3,000 times half. So half of 3,000 is 1,500. 0.2 is 300. So you need 300 inch-pounds in order to get this to slip. So 300 divided by 12 is 25. So 25 foot-pounds. Oh God, this thing's, yeah. This motor is running at 20,000 RPM. It's a 2.5 horsepower motor, so we'll say 2 horsepower motor. That'll develop way less than, say, half a foot-pound. And we're talking about we need 25 foot-pounds to get this to slip. So we're a factor of safety factor of over 25. So that's really incredible, actually, that anyone would put a key on that whatsoever. There's no need of having a key. So if you're lucky enough to still be in school, arithmetic, just simple arithmetic, is a very powerful tool as long as you know what you're looking at. So I dare say it rivals Google, because we took 3 numbers. All we needed to do was remember those 3 numbers, and we figured out that we got more than enough wiggle room for not having a keyway here. Now look at this. This is so weird. This is the brush housing assembly here. You take that whole cover off, and you got access to all this stuff. This is interesting. There's a nice Skookum watch spring there, and then you pull it out. That way you can get the motor out. Nice, nothing wrong with that brush. Nice big brush, lots of wear. But this is really odd. Instead of having the field windings wrapped around, they got one of these little spade connectors on here. So these, I'm really surprised. I wouldn't trust that, because it's getting hot, it's getting cold, it's getting hot, it's getting cold, it's getting hot, it's getting cold. I don't know about that. It's definitely not nearly as good as having round, beefy brush holder with the broached rectangular keyway, and then the field winding goes around that. Here we just got a, I don't know. Not nearly as good. I do like to see a nice heavy preload spring on these brushes. Now this is a big wound watch spring, and if you look at that, that's a lot more material, a lot more spring steel than in the Makita, so you're going to prevent your brush from floating around. I like it. What I don't like though is the spade connector. That's totally chintzy. So we're getting into it now. I'm just going to pull the handle off the field winding section, and unfortunately, instead of coming in through the back door like a Makita, they go in with these big long tie screws. I don't like long screws. The longer they are, the more apt they are to bend. However, plastic body, I mean, what's going to give first, right? The plastic body is, so no big deal. But yeah, secreted on the inside. Well, I got ahead of myself. Sorry about that. I got ahead of myself. I'm all chuffed about my dead reckoning. And I got to live in the moment, because I know some freshly minted engineer is going to take me to task for making a mistake. But be in the moment. And where was I? Yeah, we didn't have a look at the motor rotor. So we got a little condom here for the back bearing, and this is a little skateboard bearing, even smaller than a skateboard bearing. It's a 607 RS. And this, I guess, is some sort of, in case it's not aligned or whatever, why can't they just put this in the plastic housing? Like, the plastic housing isn't cheap enough. They got to add a little crappy Buna N condom. Rubbish. Anyway, Other than that, yeah, the commutator bars, very nice commutator bars, skookum. So the magnet wire in this is 20 gauge. You'll recall in the hypoid saw, which was 15 amps, it was 18 gauge, larger. So this has a cross-sectional area, I had to look this up, 0.52 millimeters, and we'll just say half a millimeter, and we'll go 12 amps rated divided by half, which is the same thing as saying times 2, 24, oh, I'm off screen here, 24 amps per millimeter, which is not as good as the hypoid saw, the Makita hypoid saw. Apples, again, meat oranges, but that was running at 18 amps per square millimeter. So still not bad, but the higher the amperage through that square millimeter of magnet wire, the hotter the wire is going to get, and the sooner that the insulation is going to fail. Now the crappy Harbor Freight tools that I've had apart, they're running at about 35 to 40 amps per millimeter squared. So still half of what a crappy tool is. And getting back to this potting, this is interesting. This is an epoxy resin that they'll put on there, and that's great because I have seen, like on the Makitas, the old grinders that I buy at auction, some of them fail because it breaks, the wire breaks right here. So this is going to be long term, it's going to be great to have this on there, strengthening that wire bond. I just picked this up and I noticed this actually isn't a fan. It's a fan shroud because these tanks get indexed in the housing and then don't move, and then this moves. So I was wrong on that one. Mea culpa. And this back bearing is sealed, which is interesting because in a lot of tools this back bearing is just shielded. So there'll be grease in there and it's sealed up from dust. The shielded, there's grease in there, but it's just shielded from shit flying at it, big chunks, not from dust. And same thing with this one. These are CW bearings based in Ningbo, China. I don't think these small size bearings you can even buy from Germany, or like they just don't make them anywhere other than China. Bigger bearings, of course, they still do. But so this is interesting here. Even though this bearing is sealed on both ends, they still add a little hard plastic guard here to protect from the commutator brushes wearing and that carbon going into this housing. Now, you would think that carbon lubricates quite well because it lubricates the commutator bars quite well, so why would they not want that getting out? Or maybe it's a matter of not wanting something in. Although the graphite, I know the graphite I use that I machine is very abrasive because it's got a clay matrix. Now maybe brushes are a little different compound, but I'm sure they still have clay in them, which would make them quite abrasive. If somebody could spare a thought for that and maybe chime in with a little more expertise than I can muster, I'd really appreciate that. Holy, look at this. This is something else. Sex on a stick. Epoxied field windings. Very nice. Spared no expense. Wow. 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 And we go from just incredible overkill on the field windings to chintziness on the brush housing. You see the Milwaukee, or rather the Makita, I get them mixed up, different colors. The teal ones, they have this big, beefy, round machined bronze or brass, and it's all the way around, you know, it's well ensconced in there. Now this is just, it's just got one little bar down here that's been bonded to the plastic. So what'll happen is these get hot and they'll eventually loosen up that plastic and break off. Yeah, it's not nearly as skookum as the Makita style, that's for sure. But I mean, this is just... And here, of course, we have same old crappy rear bearing housing. Same as every tool, it's always plastic. You just can't get away from it. This is interesting how it's a gantry over top and it's not totally enclosed. It seems pretty rigid to me. Let's see what temperature this plastic can take. We're going to do a quick test of the thermal properties or the melting point of the case, but commenter J.K. Smith had commented, and it seemed legitimate. He sounded like he knew what he was talking about because he didn't start his comment with, I've got 30 years engineering experience in such and such. In my experience, when somebody starts a comment with their credentials, they're a goof. So Mr. Smith had a guess that it was PE plastic, PEI plastic, not the land of potatoes, mind you, polyethylmide something, but that it was glass fiber reinforced. So I got a little sample that I've taken from the case. We're going to burn it and see if we can find some glass fibers. Been a long time since I've done hot knives. Thank God I'm not as dumb as I used to be. Well, that is clearly glass. We got the microscope on there. And here we go. Glassy glass, glass, glass. Very cool. Well, I do believe that brings us to tea time, gentlemen, and yes, I do enjoy a good tea bag. So I'm going to do some research on that glass impregnated plastic, and I'll give you gentlemen some respite. I'm going to end the video here and give you a teaser for the next video, which finalizes the mechanical teardown, and we get into the nuts and bolts of the electrical testing. We're going to come up with some very surprising results you will find interesting, guaranteed. If I can keep your attention for a couple more seconds, I have a humble request. I enjoy doing these teardown reviews. I haven't seen anybody else on the internet do this. You're never going to find a slimy sales guy that's going to take a tool apart and tell you what's wrong with it. So if you like this kind of review, I would really appreciate it if you would take the time to share it with your friends. See what they think about it, and I appreciate your comments, your concerns, if I made any mistakes, dunderheaded lapses in judgment, what have you. Please share this vid. Now, the link's right down below. Thanks for watching. Keep your stick on the ice.